Good evening, everyone. Today's session is on linked list. Linked list that we have in our data structures. So let us see what are the advantages, how to implement linked list in our program. One by one, I'm going to share the syntax, how to use this syntax, how linked list is saved in memory, what are the pros and what are the cons that are related to linked list. So let us begin with the session. It is basically what is a linked list? It's a data structure. Now, data structure is what in which you are basically organizing your data and storing that data in a particular sequence, right? You have some organized kind of thing, right? So how to go about that? You have some data structure. Now, which kind of data structure you have? Like if suppose I'm taking an array, it could be a data structure. Whereas in an array, you can have only a homogeneous collection of data, right? And the date where the memory is allocated at the compile time, right? Whereas when we talk about linked list, whatever you are going to implement it, it is done at runtime. So this is the main advantage of using a linked list, right? Let us see some of the important points that we have in our linked list. Right. So we understood that linked list is a data structure, and data structure is used for organizing, for storing our data in the memory. Right. Now, what all are the things required for storing that? Let us start with that. Successive elements are connected by pointers. So you may be seeing in this example, a cell, a node is divided into two parts. One is the value and the second part is the address of the next element in the list. Right. And the last element of the linked list will be holding the value that is null. So whenever a node is having a null character in its address part, that means this is the last element of the linked list, right? It can grow or shrink in size during execution of a program. So basically we are allocating the memory at the runtime. So this is the main advantage of the linked list. You can even grow it, you may expand the list, you may even shrink the list in size, and that too at the execution of a program, right? It can be made just as long as required. So you may have number of items and elements in the list. It does not waste memory space. So this is one of the advantage of using the linked list, that is you are not wasting the memory. Where the compiler is, where the memory is found, it is storing that element there. And just because you have the different addresses, it is not the like consecutive locations may it is not stored. Basically it is stored where the memory is free, you can allocate this element. Where the next slot, the next block is not free, then you can move to another, search for another block. So where you get the free block, you may allocate the node. Now the first node of the linked list is called the head of the linked list, right? And you may have you may perform the different operations on the linked list. Now what are the operations that we can have in our linked list? Let us see. Keeping track of a linked list must know the pointer to the first element of the list. So the first element of the link is the start, or you may sometimes, like we are using it as a head pointer, right? Linked list provides flexibility in allowing the elements to be rearranged efficiently. You can insert anywhere, you can delete the element. So there are number of operations which could be performed on a linked list, and it is very easy to perform. Once you know the syntax, once you know the logic behind linked list, you directly use that particular part, right? Now next thing is, if we talk about linked list, each node, it is basically a collection of what? Data elements. And these data elements are connected by what? pointers. They are basically by means of pointers we are connecting it. And how we connected it, like a node is divided into two parts. The first is the first part contains the information of the element, and the second part contains the address of the next node. Now that's what I have shown you in this slide. The first part, this is what? This is the value part, right? And this is the address. This particular part is holding the address of the next element in the list. Address of B is stored in the next part of A element, right? And address of C element is stored in the B node, right? This is how we proceed. And the last element of the list will be having the address as null, right? So this is how we have our node structure in a linked list. Let us see. This is what I am telling you. The first part contains the information or the value of the element. The second part contains the address of the next node, right? So this is how basically it is a representation of a linked list, how it looks like. The first part is like you are given any list name, and then info part. Info means the value of that particular first node. This is suppose node 1, right? And in this node 1, this node has two parts. The first is the information or the value. The second is the address of the next node in the list. So this is how it is connected. And at the last, you may see at the end, we have the null value in the address part. So this is how a linked list is maintained, and the values are maintained too. Let us see some operations on linked list, right? So suppose we have such kind of linked list. A is connected to B and third element is C, and C is the last element of the linked list. Now how we insert the values, how the now we want to insert the item, that is X, in between B, C, or in this list. Let us see that part, right? Now what we are going to do is, what we have to do, we have to insert this item between A and B, right? Now we are holding the address of B in A address, in the next pointer of A. Now what we have to do is, we have to change, we have to update the address of X in the node, that is A. So this is our current node. The address of A, we will cut the connection. The address of A now points to the X node, and X node will be containing the address of B node. So this is how we insert an element in the linked list, right? So we cannot directly like say B is equal to this, A equal to this. No. So there are different steps, and I have shown you how we insert an element in the linked list. Let us see how we define the pseudo code for that. Yesterday I have discussed about the pseudo code, what is pseudo code, how we write this pseudo codes in different languages. So we will be using a simple pseudo code for insertion that I have shown you. You may have a structure, and structure name is ND, and in this structure you have defined the item data, because we have two fields in our node, the data and the pointer to the next node in the list. So that would be treated as a, because it isn't holding an address. Obviously I told you in my previous sessions also, when we have to hold the address, we will be using a pointer, right? So star is representing the pointer to the variable, and that may be, or like according to the syntax, it would be clear whether it is holding a value or whether it is representing an address, right? Now we are just closing this structure, and then we have one function, that is insert function, and in this function we are just calling the node with current as an current pointer as an argument. Why we are calling the current argument? Because we need to have an updation in the address part of the current node. So now we have created one node of temp, because we need temp node or x in terms like last example I have shown you. Temp is equal to node, and which type of node? We are just specifying how to allocate the memory. We will be using a malloc function for allocation memory, for allocating the memory space. Size of node, whatever the type of node, you may take the size of that node. Then temp next will be now holding the current next address. So the address of current part now will be assigned to the temp next part, and current next, now whatever your current next is holding, that is now pointing towards the temp, right? So this is how we basically insert an element in a linked list. Now let us see how to delete an element from a linked list. Right, now this is our list A, B and C. Now suppose item to be deleted is B. Okay, now what are the different steps to be taken for changing, for deleting these values? So you may be thinking we have to delete the connection of B between C and A and directly connecting the C address to the A part. So this is the B, which is basically we have to move the B in some temporary node and then we delete it. So this is how we are connecting it. We are putting the B part, the B node in a temp, and current address will be holding the address of C variable, right? So we have the pseudo code for this. Again the same, the syntax, same structure will be there. You have data, you have next pointer, and then you have the current pointer in your delete function. Now your temp will be holding the current next is assigned to your temp variable, and current next is now pointing to the temp next, right? Temp next is जो भी temp next में था, that is assigned to the current next, and then we free the temp. Free temp means we are deleting the element node, that is B node. So this is how we are performing the different operations on linked list, right? The main part of this list is, let me show you this thing, this part. You need to understand, like in a node there are two things that should be maintained. First part of the node is info, and the second part is pointing towards the address of the next element in the list. And I have shown you the insertion part, how to insert an element in the list and how to delete the element in the list. Now let us see some essence part of this, that is, for insertion I record is created holding the new item. So suppose I want to insert a temp in a particular linked list, I may be having a new data item, right? The next pointer to the new record is set to link it to the item which is to follow it in the list, right? And the next pointer of the item which is to precede, it must be modified to point to the new item. Now you should know this thing, it is very very important. Like whenever we delete, whenever we insert any thing. So here have you observed this thing, what we have done? This is basically we have this list. Now I want to insert any value. I may be holding that value that is stored as the, that is treated as temp, right? Now I want to insert this temp in between A and B. Now A next part is pointing towards B. Now what happens? It is we are making the connection between A and B. Now B pointer should be the start pointer, next part should be holding the address of X variable, right? So this is what these statements are telling, like what are the things that needs to be kept in mind while making the next changes in the next pointer. For deletion, the next pointer of the item immediately preceding the one to be deleted is altered and made to point to the item following the deleted item. Now you make the changes like this. Next part is we have seen the number of advantages of using the linked list. Now let us compare it because they both are data structures. Array is data structure and linked list too is a data structure. Let us see where we can use arrays and where we can use linked list. Arrays are suitable for inserting and deleting an item at the end. There is no flexibility. You can add, insert or delete at the in between. Even you can do it with the help of like we have done just now with the linked list. You are just disconnecting the links and connecting the temporary variables, or you miss a new item in the list very easily just to change the pointer values. Then random accessing any element because it is indexed, because a subscript is maintained, you can directly access the element by using the index of that variable, searching the list for a particular value. So it is very easy when you have array kind of data structure, right? Now when linked lists are suitable, when you want to insert an element, when you want to delete an element, applications where sequential access is required, in situation where number of elements cannot be predicted beforehand. So in array you have seen it is the memory is allocated at the compile time itself. So whether the program is holding the value or not, it doesn't matter. In that case the memory will be wasted, right? Whereas when we have linked list, in linked list we allocate the memory at the runtime, not at the compile time. So in that case wastage of memory is not there with the data structure that is linked list. So these are some advantages and the usage of why we call it say like this thing, arrays and linked list, right? So I hope you have understood this part why we are using this thing. Now let us see some more example. What are the types of list we have? Depending on the way in which the links are used to maintain adjacency, several different types of list are possible. So it could be linear singly list, it should be doubly linked list, it should be circular linked list, it could be any type of linked list, right? Now we have already understood the singly linked list in which we have only two parts of a node, right? In circular linked list, the last element, the address of the address in the last element will be pointing the address to the first node, the head part. So this is the type of linked list where we make a ring type of structure. All the items make a circular path. In doubly linked list, we can have two parts in our linked list. Means two parts means two addresses parts in our linked list. So in a node, whereas in single linked list you have observed that we have only two parts. In doubly linked list we have three parts in our linked list. One is the value or information. The first part of that linked list, first part of the node is representing to the address of the previous element, and the last part of the node is representing pointer to the next element. So this is how it is connected. You have the first element that is head, you have the last element that is tail, right? So we use two pointers in this, head and tail, in doubly linked list. So these are the types of linked list. Let us see what are the different operations we will be performing under this. We will be performing like insertion. Just now we have seen we can have deletion, right? Delete an element. We can search an element, but again searching is difficult in case of linked list, right? Let us see some more thing about ADT, abstract data types, that we have in our data structures, right? Because details of the implementations are now. What do you mean by abstraction? I told you in the previous series, like abstraction is required, like you cannot have your passwords as public. You cannot set your password as public. It obviously it should be abstracted, it should be privately specified. So we may have different classifier, we may have different data types through which we can secure our data too. Right, now these are some conceptual idea behind linked list. You have a list implementation and the related function, and you can traverse. What is traverse? You are just traversing the list. You are just moving under the in the list. This is the basic structure of a node, right? Suppose you have struct node and node name is student, and in student you may have roll number, you may have name, you may have age, and the pointer is next. I told you, and it will be holding the address. And then we have type structure node we have taken. Why? Because we need to define our first node, that is head. How to begin, how to create a list? Head is equal to node, and node is defined as a what type? Pointer type. Malloc and size of node. Whatever the size of node, you may use the function that is size of. Yes. So this is how we are maintaining the structure. You have head, you have roll number, like in this part we have seen. You have roll number, name and age in the stud variable. Let us see. In the stud variable we have head, that is pointing towards the first element or the start of the linked list, and it is holding the roll number, name and age, and pointer of the address part of the next element. Now if there are n number of nodes in the linked list, allocate n records one by one. How you are going to allocate? Read in the fields of the records, modify the links of the records so that the chain is formed. So you have to maintain the series, like this node is holding the value and the next part is holding the address of the next element in the list. So I think you have understood about the different operations that we can perform on linked list, right? And plus what we cannot do is, what is the disadvantage, or you may say we cannot have the direct access to any element. The elements can be accessed if we find the address of the first node. If we know that this is the first node, we can find the other elements of the list, right? Whereas in arrays we have seen, if we want to access any element, we will be using the index part, the subscript part of that array, right? And then we can access the list. So I hope all of you have understood about the differences between the linked list and the arrays too, and what are the basic operations that we can perform on a linked list, right? Now only thing is, what you have to remember is this part. If you know this architecture for doubly linked list, you have to understand this architecture. You have to keep in mind this particular architecture. The node is divided into three parts because it's a doubly linked list. You are maintaining the double links within the node. Like a single node is holding two links. The first part is holding the address of the previous element, and the next part of the element node is holding the next address of the next element in the list. And the circular list, what is a circular list? You have number of elements, right? And suppose in a single linked list, you have seen in a single linked list, the last element is holding the address of the last element is holding null. What it is holding? Null, right? Because it is a single linked list. Whereas when we have circular linked list, we have the first element would remain same. Like you have head, you have start, you can basically you can assign any name to it. The last element will be holding the address of the first element, first node in the list. That's why it makes a circular path between number of elements. So these three structures are very, very important when you are understanding the linked list concept. If you have understood this particular part, you can easily implement it through this code, the Pseudo code. You can easily understand this particular Pseudo code. Yes, right. You may be holding next. Now what is next? It is a single linked list or doubly linked list. It is a single linked list where we have only one node. One node is containing three values. What are those three? Roll number, name, and age. And the next part of this is holding the address. Next element ka address is holding in this particular node. So this is how we define and how we use linked list in a program, right? And I want to say one thing also, like when we have differences, I told you in the at the starting of this session, there are different advantages of linked list. What are the advantages? Directly you can insert any element. I have shown you direct operations like insertion in a linked list or deletion on a linked list or traversing. Traversing means you are just following the linked list. You are just following the elements in the linked list, right? Whereas in array, you can access the element with the help of index. With the help of index, you can directly access the elements from an array. But again, array has the disadvantage because the memory is allocated at the compile time. So it leads to wastage of memory. Whereas in linked list, there is no wastage of memory. You can shrink or you can grow that particular linked list. It's up to you. There is no wastage of memory. You can shrink it or you can grow it. So these are some advantages of using a linked list, right? Hope you have understood the concepts of the types of linked list, the structure that we have used, the pseudo codes, and what are headers, what are tails, what are the two parts of nodes in a linked list, right? So we will be meeting in other lectures, other sessions, and then continue with this codes. Thank you.